Hi friends, welcome to my YouTube channel. This is my first lecture on transformer. Here in this lecture we will study parts of transformer. Friends, in my previous lecture I already told you the definition of electric machines. Electric machine is a device which converts one form of energy into another. But in case of transformer, input is electric energy and output is also electric energy. That's why transformer is not an electric machine. So we can define transformer as a static device which transfers energy from one winding to another using the principle of electromagnetic induction. Its primary function is to step up or step down the voltage. It works on AC. See, this is the diagram of transformer. Here primary winding has turn N1 and secondary winding has turns N2, and both the windings are linked using a magnetic core. When input voltage is applied to the primary, then EMF get induced in the primary winding. This primary winding sets an alternating flux, or we can say time varying flux in the core. When this time varying flux linked with the secondary of transformer, that EMF get induced in the secondary winding. So in this way electric energy is transferred from primary winding to secondary winding. See, I will cover working principle of transformer and derivation in detail in my upcoming lectures, but at present we have to focus only on constructional part. So for that I think this much concept is sufficient. Now we are going to second slide, that is parts of transformer. So first part of transformer is name plate. It is metallic plate attached to the body of transformer. Being an electric engineer, you must know how to read the name plate of transformer. I will make a separate video on this. So nameplate contains all the details of transformer, like what is the low voltage and high voltage winding voltage rating, what is HV and LV current, what is percentage impedance, what is vector group of transformer, what are the position of various steps, what is quantity of oil in the transformer. These all details are carved on the nameplate of transformer. Second part is tank. It is metallic structure filled with transformer oil. Core and windings are immersed in the transformer oil inside the tank. Third part is core. Core is made up of magnetic material. Windings are wound on the core. It helps to mutually couple primary and secondary winding by carrying the magnetic flux. Next part is HV and LV windings. HV means high voltage and LV means low voltage. So these windings are wound on core and they are made up of copper. Next is terminal box. It is metallic box attached to the body of transformer which contains all the control and protection cables of the transformer. From this box, these control cables and protection cable are brought out to the respective panels. Next is Buchholz Relay. It is mounted on a pipe that connects tank and conservator. It detects the internal faults in the transformer. It is gas actuated relay. Next is contact thermometer. It is used to measure the temperature of oil and winding. Next is conservator. It is a cylindrical structure at the top of transformer. It is connected to the tank through a hollow pipe. It acts as a top-up device, or we can say that when level of oil fall inside the transformer tank, then it make up that oil level. Also, it performs the function of carrying expansion and contraction of transformer oil. The transformer oil expands on heating. So when oil expands, then this conservator takes the expansion of oil. Okay. Otherwise, transformer will explode due to oil pressure. Next is oil filter plug. There are two oil filter plugs. One is at the bottom of conservator and another is at the bottom of the tank. So both these filter plugs comes into the picture when dehydration and filtration of transformer oil is performed. Next is breather. It absorbs the moisture from the air inside the transformer using silica gel. Next is oil level indicator. It indicates the level of oil in the conservator. Next is cooling system of transformer. Basically radiator of fins performs the function of cooling. But in large transformers, combination of radiator, fans and pumps forms the cooling system of transformer. Next is HV and LV bushing. They are used to apply input and take out output from transformer. Next is transformer oil. It is paraffin or naphtha based oil, performs the function of insulation and cooling inside the transformer. Now we will locate all these parts on the practical transformer. See, here this cylindrical tank at the top of transformer is called conservator, and here this is oil filter plug at the bottom of this conservator tank. Now these are HV and LV bushings from where we apply the input and take out the output. Next is tank. This metallic structure is called tank. It is filled with transformer oil. Next is nameplate. You can clearly see this metallic plates attached to the terminal box. So these metallic plates contains all the details of transformer and they are called nameplates. Next is terminal box. This rectangular box attached to the tank of transformer is called terminal box. It contains all the control and protection cables. Next is oil level indicator. It is not visible here, but it is on the one of the faces of this conservator tank. It indicates the level of oil in the conservator. Next is radiator or fins. These are radiator or fins. They helps in cooling of transformer oil by increasing the area of surface area for heat dissipation. Okay, so radiator of fins forms the cooling system of transformer. This is transformer winding, and these windings are wound on the magnetic core. This is gas actuated Buchholz relay. It is mounted on the pipe connected between conservator and tank. It helps to detect internal faults in the transformer. And this last part is breather. Okay, it contains blue colored silica gel and it helps to absorb the moisture from the air inside the tank. So this is all about the parts of transformer. In my upcoming videos, I will cover all these parts individually in detail. Okay, now I tell you the various types of transformer. First is power transformer. It couples the electrical energy from a power circuit to one or more power circuits. Next is distribution transformer. It is part of electricity delivery system. They are generally step-down transformers. Next is auto transformer. It is a special type of transformer having a single winding. In this type of transformer, primary and secondary windings are linked both magnetically and electrically. Next is isolation transformer. It is also a special type of transformer having a ratio 1:1. It isolates grounded conductor of power system from any portion of power circuit. Next is instrument transformer. They are used to measure high voltage and current. Example are current transformer and potential transformer. So this is all about the first lecture. I hope you enjoyed this. Thank you. Jai Shri Ram.